Hello there, this is Ms. Nakayama, and today's lesson is 1.7, Combinations of Functions and Composite Functions. So, our objectives that are going to be covered. First of all, we're going to be able to find the domain of any function. We're going to combine functions, form composite functions, and then find the domain of those composite functions. Okay, so first off, to refresh your memory, for the most part, everything that you've dealt with thus far, the domain was all real numbers, negative infinity to positive infinity. But there are two special cases that you have to be aware of. One is you can't divide by 0. And then, of course, you cannot take the square root or even root of a negative number. So that brings up two things whenever you're looking at a problem and trying to find out what the domain is. Okay, first off, as I just said, you're going to set the denominator, find out what makes the denominator 0. We just did that a lot in the last chapter, so that part should be easy. And then the second thing that you're going to do is look and see whether or not you're taking the even root. And if that's an even root and what's underneath it can't be negative, that's a problem. Okay, that's called our radicand, in case you remember from a previous class, but that radicand always has to be greater than or equal to 0. So if you don't have a fraction or a radical, then your domain is always negative infinity to positive infinity until we get to some special things. Okay, so first off, we got find the domain of the function 5x over x squared minus 49. So it is a fraction, or what we called rational expression before. So I need to take the denominator and set it equal to 0. So my denominator, x squared minus 49, I'm going to set it equal to 0. I'm going to factor it as the difference of two squares. And then I'm going to set each factor equal to 0 and find out that x equals negative 7 or 7. So those two values of x make this thing 0. So I have to figure out how to write this domain. So what you do is think about plotting it on a number line. So I'm going to put that whole thing there. All right. And on any number line, negative infinity is all the way to the left, positive infinity is all the way to the right. And in order, it goes negative 7 and 7. Those are two of the numbers, the only two numbers on this whole number line that x cannot be. So what I'm going to do when I write my domain, if you think about how many pieces, I have 1 piece, 2, and 3 pieces. So when I write my intervals, I'm going to write them with 3 pieces. So my first one is going to be negative infinity to negative 7. And then I'm going to go negative 7 to 7. And then I'm going to go from 7 to infinity. And that's all it is. Okay, so that's finding the domain. We're also going to talk about the algebra combining functions. All right, you have the sum, the difference, the product, and the quotient. And what is most important, y'all, is understanding the notation. So if you see this, it means add the two functions together. If it's subtracting, I'm going to subtract the two functions. Multiplying does not need an operation, but if you wrote it like that, you might see the times. And then dividing is simple dividing, but the denominator cannot be 0. Okay, so look at the example of what you may have. Let f of x equal x minus 5 and g of x equals x squared minus 1. Find each of the following. So first, I'm going to find f plus g of x. All right, simple enough. Just remember that by definition means f of x plus g of x. Well, what is f of x? F of x is x minus 5 plus, what's g of x? X squared minus 1. And when I add those together, I'm going to get x squared plus x minus 6. And that's my answer. That is all it is, combining like terms to get from this step to that step. Okay, now to find the domain of f of x plus g of x, well, what is the domain of this function here? Y'all know there's no fraction. I just talked about there's no fraction, there's no radical. It's negative infinity to positive infinity. Again, no fraction, no decimal. It's negative infinity to positive infinity. And if you look at our final product, sum right here, again, no fraction, no decimal. So my answer is going to be negative infinity to positive infinity. Okay, that was combining algebraically. So just follow the rules, plug in appropriately, combine like terms, or simplify if needed. What if it's a picture? Okay, so some people get stumped by this, but y'all, it's a lot easier than you think. Okay, f plus g of x. Remember, I'm just adding the two. So go to the picture and tell me what f of -1 is. Well, f is the blue line. So if I go to -1 and I go up to the blue, I'm going to be at 2. And then I'm going to add whatever the g value is. Well, the g value is red. At -1, it is equal to 3. So 2 plus 3 is 5. Same two numbers. You got to know the notation. If it says FG, there's nothing in between it. And whenever we don't have an operation in between them, it does mean multiply in math. So that's just going to be 2 times 3, which of course is 6. All right, how about f minus g of 3? So f of 3 is right here. That is, of course, -4 minus g of 3 goes up here to 1, and 4 minus 1 is -5. F of g of 0, the answer is not 0. Be careful. Okay, what is f of 0? Here is 0. So f of 0 is 1 times g of 0 is 2. And so 1 times 2 is 2. And that's all that is. Okay? If you have any difficulty with that or need more examples, please come see me. Okay? That was combining functions. This is composite functions. Okay? The composition of functions. All right, y'all have seen this. Some people call it fog or golf. But this right here is your definition. Okay? You just have to know that this is what it means when you see this. Okay? It is referred to as the composite function. And you have to remember that it talks about the domain, but I'm going to go do some examples. All right, so I'm not going to get bogged down with that. Let's keep going. All right, forming composite functions. So y'all, I've been doing this a long time. I still write out the rule every single time. So given f of x equals 5x plus 6, g of x equals 2x squared minus x minus 1, find f of g of x. So f of g of x looks like that. That's f of g of x. So you just kind of erase the 0, the little o in between them and put the parentheses. But just know that g is in the middle. And when you have multiple parentheses, y'all, you start on the inside. So I'm going to go replace g of x with what g of x is. Well, what is g of x? G of x is that. And so I'm going to go take it. So that next step, and I know y'all don't like to write all these steps, but I'm going to do it to help people. So that means I'm going to write f of, and what is g of x? We just said 2x squared minus x minus 1. Now what? Well, basically, I have to take this 2x squared and go put it into f of x, for x. So I write the rule for f of x. All right, and that says 5 times whatever you have in here plus 6. 5 times whatever's in here plus 6. Well, what's going to go in there, of course, is my 2x squared minus x minus 1. So I multiply that out. I get 10x squared minus 5x minus 5. Carry down my plus 6. And when I simplify that, I'm going to get f of g of x equals 10x squared minus 5x plus 1. And that is all that we have to do on that one. Now, I'm going to talk about that domain that I kind of skipped earlier. All right. So when you are finding out what your domain, that's supposed to be a symbol, not a circle. Anyway, when you're finding out your domain of a composite function, you want to look at the domain of g, that is your inside function, and then you look at the domain of your final composite function. Okay, the final composition. So look at this example. First, and y'all, this is coming back to you, P.6d is what this was. Okay, so given function f of x, 4 over x plus 2, and g of x, 1 over x, find f of g of x. Okay, so as I said, I'm going to write that rule, f of g of x, and then I'm going to go replace the inside, starting on the inside. So that means that's going to be f of, what's g? Well, g is this guy right here, so that's going to be f of 1 over x. And then I'm going to go write the rule for f. This is the rule for f. So I'm going to write 4 over parentheses plus 2. And what goes in my parentheses is g of x. So in this case, it's 1 over x. And this is what we did in 6.d. Okay, we found the least common denominator. This was the easiest way to do it, y'all. Find that least common denominator, in which case is x. So I multiplied top and bottom by x. And on the top, I'm going to have 4 times x. On the bottom, 1 over x times x is 1 plus 2 times x, which is 2x. And that's our answer. So that's the composition. Now, on the second part of that, we got to go find the domain of that composition. So I'm going to carry that from what we just did on the slide before. That was my composition. Now I have to go figure out the domain. And so it's always a good idea to find the domain of everything. It's a good practice. So in F, my domain is x cannot be negative 2. G of x, my domain is x cannot be 0. Okay? When I look at this new function, 4 over 1 plus 2x, I'm going to take that denominator and set it equal to 0 because I have a fraction, and that's the final, that's the restrictions I have. So then I'm going to subtract 1 and divide by 2. So I have that x is not negative 1/2. So what I said earlier, when you're trying to find that composite, you're looking at the inside, which is this guy right here, and you're looking for the final one. And that's the domain of my final one, basically what it can't be. That's probably what I should have said. X can't be negative 1/2. X cannot be 0. X can't be negative 1/2. So I'm going to draw my number line, and I have to put them in order according to the number line. And I'm putting negative infinity and positive infinity because it's going to help me write my intervals. Okay, so when I write those intervals, I'm going to have 3 of them. All right, so my domain of my composite function is negative infinity to negative 1/2, and then negative 1/2 to 0, and then 0 to infinity. And that is all there is to composite functions and combining functions. So I hope you wrote down some important concepts to help you master these. And thank you so much for watching, and y'all have a great day.